Hello, everybody. Thank you for joining me and taking the time to watch this video. Today, I want to talk to you about some key principles that I would recommend you follow when you're designing a vertical farm. I'd like to start by saying that I think there's lots of good content online that's available in video or in articles that discuss the basic, gives viewers a basic introduction to what vertical farming is and the trade-offs between growing vertically versus growing on a single level. And even though I don't always agree with those trade-offs or that discussion, I thought really hard about how I could add value to the existing content and perhaps go a bit deeper in a 40-minute presentation. So what I want to do today is I'd like to focus on what I think is the principal question that you have to ask yourself when planning to build a vertical farm, and the principles that guide answering that question appropriately. So what I want to do is I'm going to introduce myself and some organizations that were very important regarding my current understanding of vertical farming. Then I'd like to very quickly discuss, the key reasons people find value by growing vertically versus growing on a single level. And then I want to talk about that question, that key question that's different when you're growing vertically. And what that question is how many levels should I grow on? And the factors that drive the answer to that question come down to light intensity, appropriate light intensity, and business flexibility. And then finally, I'll close with a couple simple examples that demonstrate those concepts. So my name's James Eaves. I'm an agricultural economist and a professor of management at Laval University. And my research for the last 20 years focuses on methods and technology we can use to improve the profitability of growing indoors. And my ultimate interest is helping to enable what I like to refer to as self-driving indoor farming or self-driving vertical farming. Perhaps the greatest single contribution to what I know about vertical farming came from the privilege of being able to work with GreenSeal Cannabis Company, first as a research partner and then as their head of R&D. GreenSeal Cannabis Company they grow vertically, cannabis vertically, on up to 6 levels now in Stratford, Ontario. And another thing that's really interesting about them, besides the fact that I think they're most likely the tallest vertical farm in the world for cannabis, at least. What else is really interesting about them is their whole business strategy is based on using rigorous experimentation to identify technologies and methods that not only improve product quality, but also drive down the cost of operating the facility. And I think because of that discipline, they've developed a national reputation in Canada as being one of the best run cannabis companies. And moreover, in 2019, they were, Chad Morphy, their master grower, had the honor of receiving Grow Opportunities, or being nominated, being one of the recipients of Grow Opportunities, Canada's top growers. I had to leave for family reasons. I had to move out of Ontario and resign from GreenSeal. But luckily I had the opportunity to work with VoltServer, and VoltServer was the company that supplied, I first started working with them as research partners with GreenSeal. And then VoltServer supplied GreenSeal their power distribution and lighting platform. And VoltServer invented something called digital electricity. And digital electricity, it's a completely new form of electricity, and what it allows you to do, it's actually high voltage electricity that you can touch, and so you can install it legally without the use of electricians or many of the safety features that traditional electricity needs, like conduits and breakers. And it's simply the safest, most efficient way to deliver electricity that exists. And it also, because of the technology, along the same cable, you can transmit data. They have 1,000 large installations around the world at this point, including hospitals, Super Bowl stadiums, airports, and several indoor farms. And to support their indoor farming customers, we recently produced a 520 watt LED with a centralized remote driver. And that's this green box, these green transmitter, green server looking things over here on the left. And so what that does is none of the lights actually in your grow space have drivers. All that equipment, hundreds of thousands of electrical components, are removed from the grow space. And that significantly, that removes heat and saves space, but also reduces your electricity consumption. So perhaps the most basic question is, why would someone grow vertically versus growing on a single level? And to summarize a quote from Chad Morphy, again, the master grower at GreenSeal Cannabis, we grow vertically, or we find value from growing vertically when there's some constraint or some limiting factor that makes it cheaper and faster to add levels, right? To add capacity by adding levels in a room versus adding more surface area. Often that limiting factor is just regulations that mean that your permit for growing cannabis stipulates that you can grow cannabis within a certain footprint, right? Rather than having a limit based on a certain number of plants. And so you can increase your production capacity by growing up, by building more levels. Or it might be regulation just makes it costly or very slow to increase your footprint. Another common reason is that it's just expensive. Like you're in an expensive part of a city or of the country, and the cost for construction or cost of real estate, it makes it expensive. So any factor that makes it cheaper and faster to grow up is a primary reason people build vertical farms. Now, another reason I'm very excited about vertical farming is this. And what you see here is you're watching, these are pictures, different videos from automated high density warehouses. And so I have a strong belief, and many people do, that agriculture in the next few years, the winners in this space are going to be the ones that successfully automate. And I think that because of all the R&D investment that's been made into learning how to automate high density warehouses, which basically use the same infrastructure, racking and shelves, as vertical farms, by building vertically and using more or less standardized pallet racking, for example, you're placing yourself in a position to leverage all the R&D that industry has done to improve automation and drive down the cost. And so if you're interested in vertical farming, I would watch this industry very closely. Okay, so to begin, I'd like to, I challenge you to think about, if you're going to design vertically, if you're going to design a vertical farm and grow on multiple levels, what questions are new questions that you have to answer for vertical farm design that you don't have to answer when you grow on a single level? Right? For instance, certain questions stay the same. right? You still have to determine your total production capacity, the size of a room, how big your batch is going to be, what strains you're going to grow, what type of lighting you're going to use, how you're going to distribute space between veg, drying, and flower, right? How am I going to design drainage? And an extremely important question is, how am I going to design my HVAC and air distribution? And you might say, oh, well, someone who's thought about vertical farming might say, oh, well, HVAC and air distribution is, that's very different for a vertical farm. And I agree, it is very different. It's more challenging, but you go through the same process when you're designing a vertical farm as you do when you design a single level farm to develop an efficient HVAC and air distribution system, right? That doesn't necessarily change. So that's not one of the questions. I would argue that is not a question that changes when you design vertically. But just because it's such an important question, I just want to talk about it briefly, because getting into HVAC design for any type of farm goes beyond the scope of a 40-minute presentation, and frankly, it's beyond my skill set. But what I will recommend is that when you design a vertical farm or any farm, don't design blind when you design your HVAC. I think often growers, when they're designing their facilities, they're thinking about HVAC design. They have the sense that you can't really anticipate what the HVAC performance will be in advance, right? Or they assume that it's that a basic design, HVAC design, as long as you calculate the amount of heat they need to remove from that room and water, that it's going to be okay. But the fact it's not. It's like the biggest problem that growers face is that they miss or they don't optimally design their HVAC and air distribution, and so they end up having to buy expensive equipment afterwards in order to try to compensate for a poor design, or because they changed something, right? They added more powerful lights or they added more plants. But the fact is, you don't have to go into this blind. There's simulations, computer simulations you can use, right? So I'm showing you an output from one here from a fluid dynamics simulation that will allow you to simulate how your room will perform in terms of like climate variability and temperature distribution before you actually build the room. And then you can experiment with things like HVAC capacity, the placement of your air diffusers, what the impact of adding another rack or another level will do to that distribution of environmental variables through that room before you start building. And so I highly recommend paying for one of these simulations. They probably cost about $25,000 in order to hire someone to build one of these, to do one of these simulations for you. But the equipment, just put it in perspective, equipment you'd have to buy afterwards in order to compensate for poorly designed HVAC is far more than $25,000 per room. Okay. And just to talk about a myth about people often hold about vertical farms is that, and I hear this often, you can't grow vertically. Every time you grow over, every level you add, every additional level has a half a pound less yield per table because it gets warmer as you go up or something, or it's impossible to maintain climate 20 feet above the floor. And it's just simply not true. I have seen very poorly designed vertical farms where the temperature increases 3 or 4 degrees each level. But I've seen, like, for instance, the first photo when you saw GreenSeal 6th level vertical farm, there's probably a 1.5 degree difference between the bottom, the ground level, and the top level, right? They have a very consistent environment. I've seen 3-level vertical farms that are powered by HPS, that have used HPS lighting, that have extremely stable environments, consistent environments across those rooms in all dimensions. So there's not a physical or constraint that prevents you from growing on multiple levels. It's just basically good design. So back to my original question. So what are the new questions that you need to answer when you design a vertical farm? And my argument is, or claim I'm going to say here, and I'm happy to be challenged, is that the principal question that's new is how many levels, right? How high do I build, or what's the channel height of a bay? And I'm going to use those interchangeably, the number of levels or the total height. So I think that's the principal question you have to answer when you're thinking about what differentiates designing a vertical farm versus a single level farm. And the answer to it, I'm going to start with a kind of annoying answer that's a little ambiguous, is, well, the number of levels you should build is a number that maximizes your revenues and optionality. And what I mean by optionality is just business flexibility, like that gives you options to make changes as your business evolves while managing risk. And I'm going to give a slightly less ambiguous answer to that question. And the answer is that when you're determining how high or how many levels you want to add, right, it basically comes down to your channel height, right? Because suppose you want to build, you decide you're going to build, 15 or 20 feet high, then the number of levels will depend on the channel, the height of each channel, right? It will determine how many levels you actually have in that room. That's why I use channel height and number of levels interchangeably, because by choosing your channel height, you've effectively chosen the number of levels, right? And so you want to choose a channel height that accomplishes two things, right? First, it gives you enough flexibility to make changes, right? For instance, it gives you enough flexibility to change your strain, or to change your growing strategy, or to add, say there's a new technology. I can't even imagine what it might be, but it has to fit into that space, right? You can't anticipate what it's going to be, but you want to have the option to grow different strains or use different growing strategies, right? That option, when is in finance, we call it option value, right? And it's something like investors will consider. It literally has an impact on the value of your company. The flexibility to make changes has a concrete impact on the value of your company. And the second thing is you want to choose a channel height that optimizes the amount of light that your plants receive at every phase of their development, right? And what you're going to see is you can't choose these independently. My channel height, right, is affected by the amount of light, by the power of my light, and the power of my light that I decide to use will affect my optimal channel height. Okay. And this, I would just to emphasize the importance of optionality or option value or flexibility. Here's a quote from one of my colleagues, a cultivation engineer at VoltServer, but he designed and ran the Slater Compassion Center. That was for a long time one of the largest cultivation facilities east of the Mississippi. And he told me, he's like, I had to manage 200 strains, and each of these strains had a different, I would use a different growing method to optimize the growth of each of these strains. And our customers always wanted variety. They always wanted new strains. And so the fact that every strain required a different growing strategy, and he's like, I just can't, I couldn't, the height of the channel, right? When I'm growing, my growing environment, right? In this case, the height of the channel that I grow on can't constrain me, right? It has to be flexible enough. I have to have enough space to modify my growing methods and modify my strain so that I can respond to customer demand. Okay. So I'm going to talk about two things. The main thing here is I'm going to talk about, well, what is the optimal amount of light, and how is that affected by channel height? Okay, first. And there's been a lot. So first I want to talk about research about how much light is required to grow cannabis. There's been, academics, we haven't been able to do research on this plant, on cannabis, until very recently. And so, but now we're seeing a consensus in the academic community regarding how much light this plant needs. But before I get to that, I want to give you a couple definitions. So on the right here, you see this image of a sprinkler sprinkling water into and around a bucket. Okay, this is just an analogy. So imagine that sprinkler could also be a light fixture, and photons are flowing out of that light fixture, and the bucket is your plant. And some of those photons are hitting your plant, and some are hitting walls and alleys, walls and alleyways, aisles, excuse me, alleyways. Okay, you'll often see this term when you're looking at lights called PPF. Okay, and what that is PPF is the number of photons, or in this case, drops of water, that are being emitted by the light, or the sprinkler in this case. Okay. And the units for that are micromoles per second. How many, and a micromole is just a quantity, it's like 6.2 trillion. In other words, 6.2 trillion photons are being released by your light every second. Okay, so it's a measure of flow, a measure of flow of energy. But you as a grower, the measure you should be specifically interested in is PPFD, okay? And that's actually the number of photons that actually hit the plant, that actually fall into that bucket, right? And that's, in other words, the number of photons that hit their target, and that's measured in micromoles per meter squared per second, right? So when I'm talking about light intensity, the meaningful measurement, right, for me as a grower is PPFD, whereas often you'll see PPF, lighting companies will report PPF because it's a bigger number, right? But the one that you should really dig down and find is PPFD, because that's the amount of photons that's actually hitting your plant. Okay. So as I said, I did, I met GreenSeal first because we did this major research study together, actually with GreenSeal and VoltServer. We conducted the first and largest lighting experiment related to how to grow cannabis, or with the optimum amount of light to grow cannabis. It was related to spectrum also, but I just want to focus on light intensity. And so we basically installed every major light that that was on the market, and we grew cannabis actually under that we published it after 3 rounds of this experiment, but we continued to do it for a couple of years. And we just recently published in a prestigious journal, agronomy journal, the results. And what the results showed was that yields continued to increase up to 1,500 ppfd. Okay, and that 1,500 may mean nothing to you, but to put it in context, 1,500 ppfd is about twice the light that's produced by a 100-watt double-ended HPS, or twice the light that's produced by a 650-watt LED, which is kind of the standard LED HPS replacement right now in the market. So that's a really interesting point, really important point. Right now, the vast majority of growers, not to their fault, it's just the research wasn't there, are probably giving their plants about half the amount of light that's necessary to maximize yields. Okay, and like I said, there's a growing academic consensus, where I'm not the only researcher that found this. Bruce Bugbee from Utah State University, his studies are showing that they can go up to 2,000 ppfd, right? And he said 2,000, and yields keep going up. And just to give you some context, and that's also supported by Chandra, who's Professor Chandra, another professor at University of Mississippi, that found that net photosynthesis was maximized at 2,000 ppfd. And to put it in context, 2,000 ppfd is the amount of sun that's shining on the earth at midday in July with no clouds. So it's not entirely surprising that the plant evolved to be able to use that much light, since it's a field plant. cannabis. Okay, so whenever I talk about light intensity, about how much, because, you know, like I said, most growers don't have experience growing under that level of light intensity. I just want to emphasize that when you're growing at 1500 plus ppfd, you need to make sure you get your other inputs right. It's like you're driving a car really fast and you have less buffer to make mistakes. And so you really have to, monitor your inputs, especially water and CO2. Okay. So now, and I'm going to just kind of quickly explain how, with that knowledge that that maximum yields are maximized somewhere around 2000 ppfd at the height of the plant's maturity. How do we combine that with channel height in order to think about maximizing revenues and option value and reducing risk? Okay, so here's an example. Suppose you're growing vertically and you select a 5-foot channel height or bay height, right? This little space right here, right? Between the plants and the next level above. That's 5 feet is a very typical channel height for growers. Let's also, and we're going to imagine that we're using a 650 watt LED to irradiate those plants on that table. The first column is the week of flower that we're in. The second column is the height that this particular strain reaches at the end of each of those weeks. The third column, canopy distance to lights, is just a distance between the top of the canopy and the lights. And the last column is the optimal ppfd given the stage of development of this plant. For instance, at week 1, the optimal ppfd is somewhere around 700 ppfd. And it increases, you see the ppfd increases as the plant matures all the way up to a potential of around 2000 ppfd. Because the plant's gaining mass, but it's also moving closer to the lights. Okay. So I added 2 new columns. First is ppfd provided, right? So this is an estimate of the amount of ppfd that a 650 watt LED will provide to this plant, right? That's 48 during week 1. That's 48 weeks away, 48 inches from the light fixture, right? You might know that as I move away from the light intensity decreases because if we go back to that image of the sprinkler spraying into the bucket, if I move the sprinkler away from the bucket, make it higher, more will fall outside the bucket, right? If I move the sprinkler closer to the bucket, more of those photons and more of that water goes into the bucket, right? So when the plants are young and they're far away from the lights, they're receiving less light from the lamp, right? And so you see the ppfd provided by this lamp, right, increases, not because the intensity of the light is increasing, but because the plant is growing towards the light. But the issue is we have 2 problems here. First, when the plant is, you see the deficit, ppfd deficit, and that's just a difference between the optimal amount of ppfd and the actual ppfd that's provided. And you see that it varies, even though the plant grows towards the light, and so light intensity is increasing, simultaneously, the plant's need for more light is increasing also, right? So all the way through this plant life cycle, right, this 650 watt LED is just it's not providing enough light. And the deficit just varies as we move, as the deficit varies, but there's always a deficit. And the implications of this example is that the plants are receiving only about 50% of the optimal amount of light, which means that your yields are going to be up to 50% lower somewhere, because we typically go by this 1% rule. If I reduce light intensity by 1%, I reduce the yields by 1%. Okay. But another interesting thing that we found is that when you provide the proper amount of light intensity, the flowers mature faster. So if you're providing too little intensity, it's going to take longer for your flowers to mature. Okay, so now let's think about ways that sticking with this example of the 650 watt light, how I can address this problem, address this deficit, reduce the deficit. Okay. One thing that I often see is that growers will veg their plants longer, right? When they have a plant that grows shorter, right, and they know that they have this intuition that if the plant is it's wasting light when it's far away from the light, they'll veg the plant longer so they can put a bigger plant into that bay, right? So it'll be closer to the light and get more light intensity. The problem is you can't cheat physics or biology. If during veg you're not providing the enough ppfd or enough light intensity, the plant is still going to have lower yields and develop more slowly, right? Even if you provide a higher average ppfd when you move it into the flower stage, right? And regardless, like we saw, the deficit is going to persist in the final weeks anyways, because even like we saw on that table, even at the end, when the plant was 6 inches from the light, it still wasn't receiving enough light. Okay. And another thing is, like, if you have larger vegging plants, the other implication is that you have to use more space for vegging, right? And so which takes away space from your flower room, which is where you're generating your revenues. Okay. The other option is you shorten your channel height, right? I add more channels, or I make the distance between the table and the light smaller. Okay. The problem is now we're getting into when you're reducing your option value, right? You might have some strains that grow, 30 inches and others that grow 60 inches, right? And by shortening that channel height, you're preventing yourself or making it more difficult for you to grow the 60-inch plant, right? So you're reducing your options. So it's harder for you to respond to your customers. You lower the value of your company. Okay. This is a thing that's interesting to me. I've thought about a lot. I've seen growers do it. Is that, well, what I can do is I can put a mechanism or a motor or something in that allows me to adjust the height of my lights. So I can always keep my lights right above my plant. And that's interesting. The issue is, though, there's a couple issues with it. First is that we've thought about this a lot, and it's very hard to do that in a cost-effective way. It's not the cheapest way to do it, to provide the optimal light intensity. The second thing is this, it comes from this quote from Chris Murray, who was instrumental in designing GreenSeal's vertical farm, was that it adds complexity, right? And the rule he follows is simplicity. He's like, never add complexity into the building environment, because every piece of material, equipment you put in there, you have to service. And typically when something breaks and you have to service it during the day when the lights are on. So you're disrupting your production schedule, right? So his rule is, he's always biased. He's always asking himself, what can I remove from this room? Does this piece of equipment have to be here? And so this whole thing is always have the bare minimum of equipment installed near your crop. Right? So I'm going to give you another potential solution here. And the solution I like the most is, look at the strains you have, right? And think about your different ways you might grow those strains, right? And make an estimate of what's the maximum amount of space I might need. Then add a little bit, right? A little buffer for making mistakes. So once you have that space, now you want to choose a very high intensity light for which you can change the level of intensity on that light, so that no matter how far those plants are from the lights, you can always provide the adequate or optimal amount of light, right? So here's this example again. So I just redid the same example, but now I added a 1520 watt LED, right? And this column now is the output, percentage output power output for the LED, right? And so you see here is that when the plants are far away, you're cranking up the power, the output of that LED. And then as the plants move closer to the plant at different stages, you're varying the intensity so that you're always delivering the optimal ppfd all the way up to this potential 2000. So you're keeping your ppfd deficit close to zero. Okay. So there's a couple other factors to consider. I just want to say quickly at the end of this, right now, towards the end of my presentation, which we are there. When you add levels, you should evaluate, everything's an ROI, right? I'm always evaluating a decision I make when we're designing a facility in terms of ROI. What are the costs and benefits of this decision? And you do the best you can to actually using Excel to estimate the costs and benefits. And one is when I grow on multiple levels, each time I add a level, I add potentially operational complexity, right? For a simple example is I might have to buy a scissor lift, right? And then I have to train people to work on a scissor lift. And then for those people, when they're moving pots out of the tables, they have to move them up and down on the scissor lift. So it can impact your operational costs. I'll tell you though, it's not going to, if you do it well, the impact on your operational costs is going to be insignificant compared to the revenues you generate. Because we monitored at GreenSeal, we monitored like the amount every task took to the minute, right? And the amount of time it took to basically manage, do plant care and harvest for upper levels, it just didn't add a significant amount of time, right? It did, but you just didn't, when you compare it to the revenues, it was insignificant. There is an issue that you should consider, and it's also risk. Right now, you're moving people up and down 20 feet high. There is a risk, operational risk, someone could fall, right? And so you want to think very carefully about the strategies to put in place to manage that risk. The other thing, and this is, I think, a more important issue, is monitoring, right? Because it's not easy just to simply walk by the plants and check them out when there are 6 levels or how many ever levels high. Things can happen that you're less likely to catch problems. For instance, if one of your irrigation hoses is plugged on level 5, right, and stops watering, these plants are under high intensity light, and they're, the plants will die very quickly, right? Or you might have pest infestation you don't catch, or powdery mildew or whatever. So when you think about building high, you want to also think about good ways to monitor, right? What's the cost-effective way to monitor? And I would just recommend cameras and local sensors, right? Distributing like inexpensive sensors and cameras around on upper levels, especially to be able to monitor these potential risks. Okay, so in summary, constraints drive the benefits of vertical farming. Constraints that make it less expensive, all right, or faster just to grow up, right, to build upper levels. Like I'll tell you, in Canada, often, especially a couple of years ago, you might be able to grow out, right? But you might be able to add a room, might legally be able to add a room, but the process to get that room approved might be 6 months, whereas it might take you 2 days to add another level to an existing room. The critical question you have to ask when you're designing a vertical farm is, how many levels do I grow on, right? And that answer will come down to the answer that maximizes your revenues, maximizes your business flexibility or the option value you create, right, and minimizes your risk, is to select a channel height that's a little bit bigger than the highest plant that you think you'll grow, and simultaneously selecting a very high intensity light that will allow you to provide optimal lighting at all stages of the plant's development. And so I just want to emphasize that you start with, because give yourself a buffer. Start with more height in this high intensity LED, right? And then after you get that under your belt, then you can actually focus on ways of like even reducing that channel height, right? Once you become familiar with the strains you're growing and how tall they grow, and you're more confident about the production process you're using, growing process you're using, then you can actually do calculations to optimize that channel height even more. But I strongly suggest that once you move to vertical farming, you give yourself a little more space than you think you'll need, because it's a learning curve. Okay. And finally, when you're thinking about the design, for every component of that design, ask yourself, do I have to have this in my room? Is there a way to take this out of the flower room, this piece of equipment, right? Because simplicity is the key to designing an efficient facility, right? So have a bias towards simplicity. Question everything that's in that room. All right, thank you very much. I love talking about this topic. I love talking to growers. I surely learn more from you than you learn from me. So please feel very comfortable. If you have any questions or just want to connect, you can connect with me on LinkedIn and ask your question, or you can write directly to my university email. Have a good day.